In the picture below, we have triangle DEF that has been dilated from center O by a scale factor of r equals 4. It is noted by D prime, E prime, F prime. We also have D double prime, E double prime, F double prime, which is congruent to triangle D prime, E prime, F prime. Describe a sequence of dilation followed by congruence, which is rigid motions, that would map triangle DEF onto, or D double prime, E double prime, F double prime onto DEF. So we are going to start. We know if we're starting with the double primes and working back to the original, that we will change the scale factor by flipping it over. So we will dilate from the origin by r equals 1/4. This right here is 0, negative 4. 1/4 of -4 would be -1. So this would be our new E. This point down here is -4, -12. If you do a fourth of that, you get -1, and 12 divided by 4 would be a 3, so -1, -3. And then for D double prime, this point is 4, -8. A fourth of 4 is 1, and a fourth of -8 is -2, which is right here. So once we have dilated by a scale factor of 1/4, we need to translate, and we are going to go up 1 and right 2. And that will move the triangle onto this one. So that is how we would show they are congruent. In triangle ABC, this was dilated from the origin by a scale factor of 1/2. The dilated triangle is A prime, B prime, C prime. Another triangle, A double prime, B double prime, C double prime, is congruent to A prime, B prime, C prime. Describe a dilation followed by rigid motions that would map A double prime, B double prime, C double prime back onto the original. So if we are starting with the double primes and going to the original, we need to use a scale factor that enlarges it. So we're going to go from 1/2 and we're going to flip it over. So dilate from O, the origin, by a scale factor of r equals 2. 2 over 1 instead of 1 over 2. This is going to double our points. So I have -10, 3. If I'm doubling my points, I end up at -26. This point is -12, 4. So 12 doubled would be 24, and 4 doubled would be 8. Then this point is -11, and it goes through the 5. So that would be -22 and 10. Oop, no. Accidentally moved my picture here. There we go. Okay. Then this needs to be moved. We need to move it. So this is C, this would be A, and this one would be B. So we will translate. We're going to match up C with C. So we're going to translate until we hit over there, which would be from 20 to 6 would be 14. So yeah, this one's at 6 and this one is at 20. 14 units right. And then if the C is at 6 and this one is at 4, we need to go down 2 units. That will match up C with C, but then I need to flip it over so that, because right now it's going to look like this. So I'm going to have to reflect so that it matches up. And this is where x is on -6. So we're going to reflect over the line x equals -6, and that's going to flip this over here onto this side. There are other ways that you can do it. If you were to match up b with b prime or vice versa, or if you used a instead of c, it would look a little bit different, but you can still get a correct answer as long as your explanation is thorough and correct. 3 says, are the two figures shown below similar? If so, describe a sequence that would prove the similarity. If not, state how you know they are not similar. Is there any way I can translate or dilate this shape to get it to turn into this one? No. These figures are not the same shape. So even with dilations and rigid motions, these will never map to one another or be similar. They're not the same shape, so no matter how we increase the size or move it across the paper, it is never going to be the same shape, so they are not similar.